Hi guys, so I'm starting this Java concurrency and multi-threading playlist. So a lot of students were messaging me like they are really confused about multi-threading. So I'm starting this playlist which will help all the students, freshers, even working professionals to understand how the multi-threaded environment works inside Java. So I promise if you will really watch all the videos in this playlist, you will really get familiar with all the concurrency concepts from basics till advanced. So before jumping to multi-threading, let's first discuss the single tasking, like how it used to work. So we all know like CPU can handle one task at a time. Okay. So in old machines, we used to have only one CPU, and what CPU will do, it will handle one task at a time, and once this is completed, and then maybe it will handle another task. So nothing was in parallel, so it was all single tasking in this case. So slowly we jumped into multitasking, so where CPU is handling one task at a time, but it is switching between application or between programs or tasks, right? So what CPU will do, so CPU will give some time to this task, and then it will give some time to this task. So it gives you an illusion that multiple tasks are happening at a time, but in background operating system and CPUs are working together so that they can switch between the applications or tasks, so that it can give you the feel that all the things are running in parallel, but that is not the case. Okay, so it's like a switching between tasks. Some time will be given to this, then directly CPU and operating system will give time to this. So that's how it works. So this was like multitasking. So this was multitasking, and this was single tasking, right? Single task. So after that, what happened? The multi-threading concept came into picture. Again, one CPU can handle one task at a time, so that is okay. But inside the applications, right? Inside the applications, the developers start creating multiple threads. So it can be thread one, thread two, right? So CPU will run this application, but inside this application, if there are two threads, so CPU will first run thread one and then switch to thread two. Again, the switching between threads is also happening in the same way like it was happening in the multitasking, like switching between the applications. So only difference is now within the same applications, multiple threads can be written by developer, so that CPU will execute the threads one by one or switch between threads so that the work can get faster. Now in modern computers, like you have like lot of CPUs, right, at one time, or you have four CPUs now, right? So for in this case, what will happen? Maybe one thread can be executed by CPU one, another thread can be executed by CPU two, right? So in this case, when you have multiple CPUs in modern computing system, the multiple threads are executing at the same time. Now it's not switching because we have introduced more CPUs, but now the real parallel execution is happening. So this is the concept which all the applications use to improve their performance. So they run tasks in background. For example, if thread 1 wants to download some data from one location, so it can run in background. Thread 2 can connect to database. Thread 3 can do some other tasks, because we have a lot of CPUs now, and every CPU can handle one thread, right? So which is the main reason that in today's world the performance of the applications are too high, so they give you response in milliseconds even if you are connected to a database, and you are dealing with millions and billions of data. Due to multi-threading implementation, the tasks can be done in very quick way. So multi-threading have a lot of benefits, like we are using the CPU in a better way, we are getting the response as quick as possible, but it comes with a lot of problems when you write a code for that. So for example, let's say both threads are managing the same memory, right? So if they both have same memory, shared memory model, then it can lead to a lot of problems, like deadlock can happen, race conditions can happen, congestion can happen, and many more, right? We will see all these things in the code also. So what I'm trying to say is, like, if like multi-threading have a lot of benefits, but managing the memory state and avoiding the synchronization issues is really a headache for developer, right? If it is not done in a right way, it can cause a lot of problems like data inconsistency, deadlocks, and other conditions. So now let's see in the Java how we can create the threads. If you're not familiar with the basic Java, I will recommend you go to my core Java playlist and see that video like how Java code runs and other basic videos. So to start the new thread, right? So you can use the thread class. So what I will do, I will create object of the thread class, and I will just use object thread object. So I will use object thread dot start. Okay. So in this way, this new thread will be started, but it will not do anything. It will just start and then it will just stop because we have not given the implementation of the run method. So now to give the implementation of the run method, what I will do, I will create here my thread extends thread. So we are here using inheritance concept. So I will here give the implementation of run method. Okay, so I will say thread 1 is running. Okay, so now when I start this thread, so you will see the implementation whatever we have given inside run method, it will get triggered. I will run this one, it will create a new thread and it will execute this statement. So this is one way of doing or creating a thread. I will not recommend you to do like use very legacy code. So we should always use functional programming and lambda expressions. So if you're not familiar with that, so you can check my this Java streams video, which will really help you. So instead of doing like this, so what I will do, so I will create thread object thread 2 is equal to new thread, and inside this I will give the implementation. So I will write the statement here, thread 2 is running, and then I will say object thread 2 dot start. Okay, so now if I will run this, so our two threads will started along with the main thread here. So thread 1 is running, thread 2 is running. So I will just remove this code. So this is just a very legacy way of doing it, which is not recommended now. So I will remove this. So here we have used lambda expression to give the implementation of the run method. Now this is also not the efficient way of creating the threads. So these days we always use the runnable interface to create the threads. So how we can do that? So I will say runnable and I will create object runnable is equal to new runnable, and inside that I will again give the implementation of run. Thread 3 is running, and then I will use this runnable task and pass it to our thread class. So I will say thread object thread 3 is equal to new thread, and inside this I will pass object runnable, and you can also give the thread name. So I will say object, so I will say runnable thread, and then again we have to use a start. Okay, so now if I will run this, so we are using the runnable interface and we are passing that to this thread object. So you will say thread 3 is running. Again here we are using the new keyword, so which is not recommended. So we can convert this code to lambda expression. So I will remove this one and I will just give the implementation like this, and I will remove run, and now our code readability is so much better. So if you see, the runnable is functional interface. So functional interface basically have only single abstract method, which is run, as the method is only one, right? So whatever implementation we are giving it here, it will automatically apply to this run abstract method. So that's why the functional interface works best with lambda expressions, because they only have single abstract method. So in this way, you can create either thread using this without runnable, which is not as efficient as creating the runnable interface and then passing that to the thread. And then we can use a lot of methods here. For example, let's say I will say thread 3 started. And then let's say we can put our thread to sleep for 2 seconds. And then we can say thread 3 completed, right? And also thread, if you're using thread.sleep, you have to use try catch so that it will handle the exception. You can also capture thread name here. So if I will say thread dot current thread dot get name, so it will give me the name. And also you can see the states of the threads. So if I will say thread dot current thread dot get state, right? So it will give you the state also. So now if I will run this, so you will see first thread 3 will start, and then we are giving printing the name, which is runnable thread because we gave the name here, and then the get state is runnable, and then thread 3 completed. You can write your execution and you can start your thread, and you can achieve multi-threading by doing this. But here, if you will notice, right, when we are running this program, so even if this thread is taking 2 seconds, right, so the main thread, our program is still running until this thread is getting completed. So that means this main thread is not getting exit until all the threads are completed. But sometimes you have to run your threads in background without impacting your main thread, because the use case can be if you want to do garbage collection, or you just want to monitor your resources, or you just want to do some logging, right? For that background task, you don't want your main thread to wait for the other thread, right? So that's why there is a daemon thread concept in Java. So by default, these threads are not daemon threads, but we can specifically set the thread as daemon. So if I will say object thread dot 3 dot set daemon, and I will say true, right? So now if I will run this program, so you will see this 2 seconds, right? So main thread will not wait for this 2 seconds, it will automatically end. So if I will run write statement here, main thread ended. So now if I will run this, so you will see after thread 3 started, right? So it didn't wait for thread 3 completed, because you can see there is no statement here, thread 3 completed. Main thread didn't wait for this thread to get completed, right? So this is the concept of daemon thread, which can be asked in the interview, what are daemon threads, and show me the code example, like the main thread is not waiting for the daemon threads, right? So you can simply create a thread, you can just set it as true, and you can show to the interviewer that main thread is getting ended without waiting for the daemon thread. So till now, like everything is looking smooth, right? But in reality, these threads will work with the shared objects, and then the issues will start coming. Okay, so I will just modify this code. So I will remove this thread, and I will just create one more runnable. Now I will just create a new threads, object runnable one, runnable thread one, and object thread one dot start, and same I will create the other thread, runnable thread two, and I will pass object runnable two here. Okay, so now we have two threads which are running, and both have their own runnable objects, right, or runnable task. So now we need to understand what is Java memory model and how the data is handled internally by Java for multi-threaded applications, right? So let's say if I create here one shared object, let's say public static object shared object is equal to new object, right? So so in this case, let's say we pass this shared object here. So I will just say dot hash code. So we will get the hash code of this shared object, and I will put same line in this also, right? So now if I will run this code, so you will see both the threads are accessing from the same memory, right? The hash code is same because the shared object is being used by both the threads, right? Understand how the Java memory model works. So inside Java, so we have here JVM. Inside JVM, we will have one heap memory, and then for each thread we will have thread stack. Okay, thread 1 stack we can say, and then thread 2 stack. So this is how Java memory model looks. So now for each thread, right, So whatever the local variables are, it will be stored in the respective thread stack. Okay, so now here I can say local 1, local 2, right? Here also, let's say local 3, local 4. So these local variables are not shared among multiple threads. They are just limited to their, so they're just limited to their own thread. So for example here, right? So let's say inside this runnable, if I will say int runnable 1 is equal to 0, right? So this runnable 1 will be stored in this stack. So this thread 2 cannot deal with these local variables of each other, right? So same way, if I will say int runnable 2 here in the other runnable, so it will be again stored in the thread stack of this thread 2. Okay, but in case of shared objects, so objects will always be stored here, right? So let's say object 1. So objects will always be stored in the heap. So let's say object 1 is there, and then object 2 is there. So now if both the threads are using the same object, so they will have reference of object 1 here, but it will point to the same location in the heap. So same way here, reference of object 1, and it will again point to the same. So in this case, if you see, both the threads are dealing with the shared object which is present in the heap. So this is when the lot of problems start, and this is when like developers have to be really careful while handling the shared objects, because it can happen like this thread is updating the value of this, but this thread is not getting the updated value, right? So all that conditions we will see eventually in this video, but this is just to give you high level flow how it looks in the JVM. And if we combine this JVM with the CPU architecture, right? So now let's understand how these CPUs will deal with the multi-threads, right? So let's say you have one machine, and so let's say in your machine you have two CPUs. So I will just do like this. So CPU 1 and CPU 2. Okay, and you will have your own RAM, which is a main memory, right? And then each CPU will have their own CPU registers. So it will have their own CPU registers, and also they will have their own caching layer also here. So this is how it looks at the operating system, right? So now if CPU 1 is handling your thread 1, right? So it will fetch all this data from the main memory, because eventually this whole data is there, right, in main memory. And now the data will flow like first to the caching layer, then to the registers, and then once the processing is done, then it will move back to the main memory, right? So same for the thread 2. So whatever data is related to that thread, it will move up to registers. Your then logical implementation will happen, and then whatever update is there, it will pass back to the main memory, right? So register is basically the space of each CPU, which helps in the processing, and it's faster. And caching is the layer in which the cache can be done for each CPU, and each registers and cache is always in the sync basically. So this is how it works. Okay, so now sometimes, so now if you will see, this is getting like little bit complicated, but this is the interesting part also, like how to handle multiple threads in multiple CPUs. That's what you need to learn. So now the lot of problems comes, right? So first problem is the visibility problem can come. So let's see the code example for that. So visibility problem is basically, let's say both the threads are dealing with this object 1, right? And this first thread will update the data for object 1, but it will stay in the caching. It, let's say it's taking some time to move that data to the main memory, and at the same time CPU 2 is trying to get the data from main memory, right, for same object. So in that case, still CPU 2 will get the old value, it will not get the value which is updated by CPU 1. So let's see how it works in the code and how we can resolve that. So let's see this example. So I have one class, and inside this class I have one boolean flag, and I have getter and setter function for that flag boolean. Okay, so what I am doing here is I am creating one thread here which will set the flag value from false to true, and it will end. Basically, that's the purpose of this thread. And so in the second thread, I am having infinite while loop until or unless the flag value is true. Okay, so it will keep running until the flag value is true. So if I run this code, so if you see here, thread 1 started and thread 1 logic started. After that, thread 2 already started, and then thread 1 logic completed and flag is set to true by thread 1 in this line. But if you see here, the thread 2 is still stuck on this while loop. Even thread 1 have updated the value to true, but thread 2 have not received the updated value here. It is still getting the value as false, due to which this while loop is continuously running. So this problem is known as visibility problem. So how we can solve this problem? Basically, so we can use here volatile keyword in Java. So if I will use this keyword on the flag, and now if I will run this, so you will see as soon as flag is set by thread 1, this while loop is over and this statement got completed here. Okay, so this visibility problem we resolved by using volatile keyword. Okay, so using volatile is one way of handling the visibility problem. We can also use synchronized keyword to handle the same thing. So in this case, if I remove the volatile keyword here, right, and I put synchronized keyword for both the methods, right, so this will also solve the problem. If you see here, as soon as the flag is set by thread 1, the loop will end and thread 2 logic will be completed. So there are different use cases where to use volatile keyword and where to use a synchronized. So let's discuss that use cases. Before jumping to difference between volatile and synchronized, let's see how it is working internally, right? In this code example, we have one boolean keyword, right? So let's say we have one boolean keyword here, right? Now the thread 1, right, which is running on CPU 1, will fetch the value of boolean, and it will process the value, like change the value here in the registers and sync that value in the caching. The updated value is already here, but it is taking time to sync it with the main memory, right? And at the same time, the CPU 2, thread 2 is running. So the thread 2 is not directly checking the value in the RAM, because when thread 2 started, it is also checking in the caching store, right? So registers keeps on checking in the caching store because while loop is running here, right? So with the help of volatile keyword or synchronized keyword, right, what we are saying to the threads is, like, as soon as you update the value of boolean, immediately you put back that value in the main memory. If boolean is volatile, right, we are using volatile keyword, so what we are saying to thread 2 is, you don't check the value from caching store, or you don't pick the value of volatile variable from here, you directly put, so you directly pick up the value from main memory. So that's why when we used volatile or synchronized, as soon as the value got updated here, it got passed to caching store, it got passed to main memory, and thread 2 immediately read that value from the main memory and ended the logic. So that's what happened in our code here. So if you found this video helpful, don't forget to like, subscribe, and hit that bell icon for more programming content.